Okay, we have our Unit 4 test coming up here, and this review worksheet should have been passed out in class. If for some reason you didn't get it or misplaced it or whatever the case may be, it is also located on our website, and so you can print it off there so you can follow along as we work through this. Okay, so this is the Unit 4 review worksheet. Question 1, we are asked which graph best represents the system y equals negative 3x plus 1 and y equals 2x minus 4. Okay, so to check this, we need to first know what does this first line look like, y equals negative 3x plus 1. Well, this plus 1 is the b of this slope-intercept form, and I know this is slope-intercept form because it's in the form y equals mx plus b. And so since my b is 1, I need to first make sure that at least one of the lines starts at 1. Okay? My m for this particular line is negative 3. Okay, and if it doesn't already have a denominator, you add a denominator by placing it over 1. And so my m shows me the movement of my line. My m in this case shows me that I'm going down 3 and over 1. Okay, so that's what I'm going to be looking for. Do I have a line that starts at 1 and that moves down 3 and over 1? Well, when I look here at my first graph, okay, I do not have any line that crosses here at 1. And so I know it can't be A. When I look at B, here's my 1, my y-intercept of 1 that I know this graph needs to start at, and there's no line that goes through that either. So it can't be B, so I'm already thinking it's probably C, but I'm going to double check. Okay, here's 1 where I'm supposed to start at. Sure enough, I've got a line that goes through that 1. Okay, and so we don't want to assume. So let's make sure that it fulfills all the requirements. It starts at 1. Okay, it needs to go down 3 and over 1. If I start there and I go down 3 and over 1, sure enough, it still follows that track. And if I check it again, go down 3 over 1, sure enough, still follows that track. Okay, so I'm pretty sure the answer is C at this point, but you know what, let's just double check that other line, make sure we haven't made an error in some way, shape, or form. Okay, with this second line, it should be starting at negative 4, and its slope is 2, which means that when I move, I'm going to go ahead and place this over 1, because I don't already have a denominator. When I move, I should be going up 2 and over 1. So I should be starting at negative 4, going up 2 and over 1. Okay, so with this graph, which I'm pretty sure is right, but let's double check. Do I start at negative 4? 1, 2, 3, 4. Yep. So far so good. And so then do I move up 2 and over 1? Well, if I count up 2 and over 1, sure enough, looking good. There's another point. There's another point. Okay, and so sure enough, we've confirmed that this is our answer. This is the graph that represents the system y equals negative 3x plus 1 and y equals 2x minus 4. Okay. Number 2, we are asked which coordinate represents the solution of the system of equations. Okay, so there are 2 ways to work through this. The first one would be to actually solve the system of equations, which we are going to do momentarily. The second way would be to take the point, for example, negative 2, 3, and plug it into this top equation and say, do I get a true statement? And if I get a true statement, then plug it into the other equation as well, and do I get another true statement? If you're able to plug in negative 2, 3 into both of these equations and get 2 true statements, then you know that's the solution. If you plug in negative 2, 3 into the 2 equations and one of them is false or both of them are false, but if even one is a false statement when I plug it in, then I know that's not my answer, and I'm going to move on to the next one. I'll plug in 2, 3 and say, do I get 2 true statements? If one's false, I'm going to cross it off. I'm going to move on to the next one. Plug it in. Do I get 2 true statements? If it's false, move on. Right? And so that would be one other strategy for solving this type of problem, because you do have a multiple choice. Okay? Here's how you would solve it with the actual systems of equations. Okay, looking at these two, I could use either strategy, either elimination or substitution, right? This bottom one would be a fairly easy one to make a substitution problem. I could subtract this 5x over. Okay, but because both of these are in standard form, it's probably going to be a little bit easier to do elimination. They're already in elimination form. And so with elimination, I'm going to be looking either my x's or my y's. I want them to have the same number, but opposite signs, one positive, one negative. And you can change either one, like I said. Okay, when I look at this y though, I see it's already pretty close to being the same number, opposite sign. I can really easily turn this bottom one into -4. Okay. And to turn it into -4, I'm going to multiply that y by -4, because then -4 times the 1 that's there is going to give me -4. But if you're going to do that, you need to do it to all the numbers. We need to multiply this one by -4 and this one by -4. You need to maintain equality. Okay, so here we go. I'm going to rewrite this top equation because I didn't do anything to it. It's still going to be 2x plus 4y equals 8. But this bottom equation is going to be -20x minus 4y equals -28. -4 times 5 is -20. -4 times 1 is -4. -4 times -27, I'm sorry, that's actually +28. I guess that's why we double check our work. -4 times -7 is +28. Okay. Now that we've got our same numbers but opposite signs, we're going to add down. 4 minus 4 is 0. 2 minus 20 is -18x. And 8 plus 28 is 36. Okay, and so then we're going to divide by -18 to solve for x. Okay, and so then we're going to get 36 divided by -18 is -2. Okay, looking at my 4 answers here, only one of those 4 numbers, one of those 4 points, have x as -2. Only A does. And so I'm already pretty sure that A is my answer. Okay, but you know what? It doesn't hurt to double check. Okay, to solve for y, you're going to take this x equals -2 and you're going to plug it into either equation to solve for y. I'm going to go ahead and choose to plug it into this bottom equation because I noticed that y, which is what I want to solve for, is already by itself. But technically you can plug it into either one. Okay, so I'm going to plug it into that bottom equation. We have 5 times my x, which is -2, plus y equals -7. Okay, 5 times -2 is -10. And then to get this -10 to come over here to solve for y, I'm going to do the opposite. I'm going to add 10 to the other side. And so we get y equals -7 plus 10 is 3. And sure enough, that does match my point. So we have x equals -2 and y equals 3. So I know my answer is A. Okay? Next one, which coordinate represents the solution of the systems of equations? Again, you could take the time of plugging each of these points in to both equations, see if you get 2 true statements, because if you do, you know that's the answer. Okay, but I'm going to go ahead and solve this using one of our algebraic techniques here, either substitution or elimination. Again, you could turn this one into substitution. You could pick one of these equations and either solve for x or solve for y. But because they're both in standard form, elimination is probably going to be your best bet. Okay. Again, you can change either one, x or y. Okay. But we're looking for them to become the same number, opposite signs. Okay. When I look at y here, I notice I don't have the same number, but I do already have opposite signs. And so I'm probably going to choose to change my y. Okay. Okay, 5 and 2, both of them I could turn into 10. Okay, if I wanted to turn this top one into 10, I would want to multiply that 5 by 2. Okay, but if you're going to multiply 1, you've got to multiply them all. We're going to maintain equality here. Okay, the bottom one, to turn it into 10, I'm going to multiply it by 5. Okay, but if you're going to do it to one, you've got to do it to them all. Okay, so this top equation, we're multiplying everything by 2. So we're going to get 18x plus 10y equals 68. 2 times 9 is 18, 2 times 5 is 10, 2 times 34 is 68. The bottom equation, we're going to get 40x minus 10y equals negative 10. 5 times 8 is 40, 5 times negative 2 is negative 10, 5 times negative 2 is negative 10. Okay, and so now that it's in elimination form, we're going to add down. 10 minus 10 is 0. 40 plus 18 is 58x. And negative 10 plus 68, or 68 minus 10, is 58. And when we divide 58 over to the other side, we get x equals 58 divided by 58 is 1. And when I look at my 4 points here, only one of them has x equal 1. Right there. Okay, and so I'm already pretty sure my answer is probably going to be D, but let's double check. Let's make sure we get y equals 5. To take this x equals 1, I'm going to plug it into either equation. Okay. You might like the bottom one because they're smaller numbers, or the top one because they're positives. Personally, I lean a little bit more towards the positive side of things. And so I'm going to go ahead and plug into this top equation. We have 9 times x is 1. Okay. 9 times 1 is 9. We're going to go ahead and now get this 9 to come over to the other side. Since it's positive, we're going to do the opposite, which is negative. And you're going to get 5y equals 34 minus 9 is 25. And then if you divide by that 5, you get y equals 5. And sure enough, it matches. So I know my answer is D. The next 5 questions then all deal with relationships on a graph. Okay, we're looking here at 2 lines. We have a g of x line and an f of x line. This, by the way, corresponds to your 4.1b notes. Okay, so we have here, for f of x, name the point of the y-intercept where x equals 0. If you're looking for a y-intercept, what we're looking for is, where does f of x touch the y-axis? Well, here's my f of x line. Here's my y-axis. F of x touches my y-axis at that point, at E. Okay. Next one, we're asked for g of x, name the point of the y-intercept where x equals 0. So where does g of x touch the y-axis? Well, here's g of x, here's the y-axis. G of x touches the y-axis at this point, at C. Okay, next up, we're asked to name the labeled points on g of x where g of x is greater than f of x. Okay. And so if g of x is greater than f of x, it means that for that part of the graph, g of x has to be above f of x. Well, if I were to test this by kind of putting a line on, I notice here that I have 4 parts. I have this piece of f of x and this bottom piece of f of x. I have this left piece of g of x and this right piece of g of x. Okay. If I put a line at some point on here, for example, here, I notice that at this location, my g of x line, this piece of my g of x line is above my f of x. And so on this side of my intersection point, on these 2 parts of g of x and f of x, g of x is above f of x. Okay, this is different than if I go on the other side of the intersection line. or the intersection point to these two parts of my line. Okay, when I look here, I notice that my f of x line is above my g of x line. Okay, and so over here, f of x is above g of x. If I want to know where g of x is above f of x, I'm looking at this half. G of x is above f of x. And so what points are on that section of that line? Well, I've got D and I've got C. The next one, name the points, name the labeled points on f of x where f of x is above g of x. Well, f of x is above g of x over here, right? We just tested that on this section of the line, because when I put my little testing line here, I notice f of x is above g of x. Okay, and so what's on this portion? Well, I've got A and I've got L. Okay, last one. Name the point where f of x equals g of x. If f of x equals g of x, they've got to intersect. That's what that equals means. Where do they intersect? Where do they touch? Well, f of x touches g of x here at h. Okay, moving on. We've got number 9 here. Number 9 says which inequality, or asks, I should say, which inequality is shown on the graph below? Name a point in the solution set. Okay, so we've got A, B, C, and D. Now looking at A, B, C, and D, I notice that we're going to call it the equation part. So what I mean by that is the part that's different than the symbol. We're going to ignore the symbol here. Okay, when we look at the components of our inequality, the equation, if you want to call it that piece, even though it's not really an equation, the components here are all the same. We have y negative 2x plus 4, y negative 2x plus 4, y negative 2x plus 4, y negative 2x plus 4. And so that's not really what I'm concerned with in this particular problem. What I'm more concerned with is which of these symbols is accurate, which of these symbols is right. Okay, when I look at my graph here, my inequality, the first thing I notice is that I have a dashed line, not a solid line. And if I've got a dashed line, that means that my symbol can't have an equal to. Okay? Because if it was an equal to symbol, then this line would be solid, which that then eliminates A and B. It's got to be either C or D. Okay, so the next thing I'm going to look at is the side, or what side of the line is shaded. Okay, when I look at this inequality, I notice that everything over here is shaded, which means all of these points over here, when I plug them into my inequality, have to give me a true statement, because all of these points in this shaded region are possible solutions. Okay? And so that's what I'm going to look at next. I'm going to go ahead and pick a point in the solution set, and I'm going to plug it into this inequality, and I'm going to say, does it give me a true statement? Or does this inequality give me a true statement? Okay, that has to be true because they're shaded. Shaded must be true. They have to be solutions. So you can pick any point you want. I usually like one of the ones on the axes because then I have a 0 to plug in. I like zeros. So I'm going to go ahead and pick that point right there. Okay, that point is 4, 0. It's 4, 0 because I went right to 4 and then I didn't go up or down at all. And I'm going to plug in x equals 4 and y equals 0 into my inequality to see, do I get a true statement? Okay, so I'm going to pick this inequality first. I'm going to put 0 into my y. 0 is greater than negative 2 times, and I'm going to put 4 into my x. And we get 0 is greater than negative 2 times 4 is negative 8, and negative 8 plus 4 is negative 4. So the question is 0 greater than negative 4? Is that true? And the answer is yes. Okay, so I'm pretty sure C is my answer, but you know what? Let's just double check. Never hurts to double check, especially if you have the time. Okay, so we're going to go ahead and then plug into this inequality as well. 0 into my y is less than negative 2 times 4 into my x. 0 is less than negative 2 times 4 is negative 8. Negative 8 plus 4 is negative 4. We just did that up above, right? It was the same component over here. And is 0 less than -4? It's not. That's false, and so that's not my answer. And so sure enough, my answer is C. Now, again, you don't have to check this last piece, but I would recommend it, especially on a test, if you have the time. Why not? That way you make sure you haven't made a little tiny mistake here, you know, forgotten a negative or multiplied wrong or something like that. You double check with the remaining answers just to make sure. That way you guarantee you got those points. Okay. The last part of these instructions was name a point in the solution set, and you can name any point. You know, I named 4, 0, so I could put 4, 0 in here, but you could pick any point in here. You know, I could pick this point here, which is at 3, 5. Or I could pick this point over here, which is at 6, 4. Right? Any of those are possible points, or any of the other ones. The ones you cannot pick the ones on the line itself, because this is a dotted line. If it were a solid line, you could pick one, but because it's a dotted line, this in essence acts kind of like a shadow on the side of our solution set. We can't pick any of them. None of those are solutions. So you want to pick one that's in here in the shaded region. I'm going to go ahead and pick that 4, 0 that I used as my testing point. Okay, number 10. Which set of inequalities is represented by the shaded region on the graph? Name a point in the solution set. Okay. So when I look at my inequalities here, I notice that again, they've all got those same components, except I notice here that my y's do change. My y ones. Right, the negative x plus y's, those are all the same. Negative x plus y, 2. Negative x plus y, 2, etc., etc. Okay, but the y -4 versus y 4. So let's start there, because I'm noticing that's a difference. Okay, we might even be able to eliminate some answers already. Okay, y4, y equals 4, if this were an equal sign, remember, is a horizontal line. It crosses through the point y equals 4. Y equals -4 is also a horizontal line. It crosses through the point y equals -4. Okay, I know that's not equals, but we're going to pretend so for now, just so we can check our line. Right, and when I look at this horizontal line here, which I know must correspond to these equations, I notice that this line goes through +4, not -4. And so I know it can't be either A or B. Okay, so it's got to be either C or D. The question is, what's the sign? Here I have y is less than 4, here I have y is greater than 4. Here I have negative x plus y is greater than 2. Here I have negative x plus y is less than 2. And so we're going to do the same kind of thought process that we did up here with this number 9, which is we're going to pick a point in our shaded region. We're going to test it. And you can pick any point you want. Okay, I'm going to go ahead and pick this point over here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, it's right in here, this point, 6, 5, and I'm going to test that. Okay, so here we go. Plugging in 6, 5 into y is less than 4. I've got my x and my y. Okay, y is less than 4. I only have a y to plug in. Well, 5 is my y. And if I plug in 5 is less than 4, I ask myself, is that true? No, 5 is not less than 4. And so I know that's not my answer. Okay, if it were my answer, this point, when I plug it in, I'd have to get true statements, right? Same as up here. You have to get a true statement. If you get a false one, okay, it's not a solution. It's not the right answer. It's got to be true. Okay, so it's looking like D is probably my answer, but again, let's double check. Don't assume. Okay, when I plug in 5 into my y here, I get 5 is greater than 4. That's true, so far so good. Let's double check that other one too. It's got to make both of them true. Don't want to assume. Let's plug in 6, 5 here. 6 is my x, so I'm going to go ahead and plug in -6 plus 5 is my y. And -6 plus 5 is -1. Is -1 less than 2? It is. And so sure enough, we've confirmed D is our answer. Okay? And so then name a point in the solution. set, which is our last set of instructions here. Again, you can pick any point in that shaded region. I'm going to go ahead and pick the one that I used to test. But again, any point works. I could pick 7, 5, for example, or 8, 5, or 9, 5, or 9, 6, right? Any point in that solution set. Okay, here we go. Next up, we've got numbers 11 and 12. 11 and 12, you're actually asked to do the graph yourself, right, as opposed to the 9 and 10 where we were just asked to identify the graph that corresponds to the given inequalities. Okay, so number 11, y is less than or equal to 2x minus 4. Okay, here we go. First things first, looking at this symbol, because I've got an equals right there, I know this is going to be a solid line. Okay. Because it's a solid line, I'm good to go here. I'm going to go ahead and not worry about the dashes. B is negative 4, so I'm going to start down here, 1, 2, 3, 4, at negative 4. And my m in this case is 2. Okay. Since I have no denominator, I'm going to go ahead and add 1. And since m is positive 2, I'm going to be going up 2 and right 1. And again, connecting that with a solid line. Okay, so here we go. Let's go up 2 and right 1. Up 2 and right 1. Up 2, right 1. Up 2, right 1. And we've got there our line. Remember, solid, not dashed, because we've got that equals. Okay, and so our next step is going to be to determine which side of that line to shade. And to do that, we're going to go ahead and pick a testing point. Make sure it's not on the line so you can figure out where to shade. I notice 0, 0 is not on the line. Personally, I like testing 0, 0 because it's an easy one to plug in. Okay, so I'm going to go ahead and plug in here 0, 0, my x and my y, into my inequality. Okay. So we're going to go ahead and plug y in here. So we have 0 is less than or equal to. Plug in x here. So 2 times 0 minus 4. So we have 0 is less than or equal to. 2 times 0 is 0. Minus 4 is negative 4. Is 0 less than or equal to negative 4? It is not. This is a false statement. And so I want to make sure that when I shade, I don't accidentally shade in 0, 0, because 0, 0 is not true. If it's going to be in the shaded region, it has to be true. So we don't want to shade this side of the line, because then I'd shade over 0, 0. Instead, I'm going to shade over here. Okay. These are going to be my solutions on this side of the line. If I pick any of those points, I'll get a true statement. And then we're asked to name a point in the solution. Okay, so any point in that shaded region will work. I'm going to go ahead and pick that one. Okay, that point is located at x equals 1, 2, 3. And y equals down 1, down 2, so negative 2. And again, you can pick any point in that region. I don't have to pick that one. I could pick this one down here at 4, negative 4. Or this one here at 5, negative 3. Or this one up here at 4, 2. Right? Any of them would work. In this particular case, you could even pick one on the line, because one on the line would be true as well, because it's a solid line. Remember, if it's a dashed line, you can't pick those points, but if it's a solid line, you can pick it. Okay. Okay, here we go. Next up, we've got number 12. This one's a systems of inequality, so we're going to do it twice. We have y is less than x over 3 minus 1. So remember, this is the same thing here as 1/3 x. Okay, so here we go. In this first one, first of all, no equals sign. This is just a less than, so this is going to be a dashed line. Make sure you're careful about that when you connect your points. This is going to be dashed. Okay, we have our b is negative 1. Okay. And then my m in this case is going to be my 1/3. Okay. Which means I'm going up 1 and right 3. Okay, so here we go. Up 1, right 3. Okay, and up 1, right 3, I ran out of graph. I mean, you could add graph if you wanted to. Technically, you only need 2 points to make a line though. You also could go the opposite direction. You could keep this pattern going in the opposite direction if you wanted to. Again, you don't have to. You only technically need 2 points to make a line. If you wanted to, you could go back the opposite direction as well. And then again, when we connect, make sure that this is a dashed line, because there's no equals to on my symbol there. You want it to be really clear that it's dashed, especially if your points are close together. Make sure it's really obvious that you made that a dashed line. Okay, so here we go again. We need to figure out which side of that line to test. I notice 0, 0 is not on my line, so I'm going to go ahead and plug in 0, 0 into my inequality. I'm going to go ahead and do that over here. Okay, we're going to plug in, here's my x, here's my y. Plug in 0 into my y, and then plug in 0 into my x, and you can plug into either one. Okay. So then we get 0 is less than, 0 divided by 3 is 0, or 1/3 times 0 if you had picked this one. 1/3 times 0 is 0. So we have 0 minus 1, which is -1. Is 0 less than -1? It is not. That is false. And so we're going to shade away from 0, 0. 0, 0 should not be in my shaded region because it didn't give me a true statement. If it's in the shaded region, it has to be true. So we aren't going to shade over here where 0, 0 is. We're going to shade over here. Okay, now because I'm graphing a systems, I want to just do kind of a light sketch here of where my shaded region is. Okay, just really light, because we're going to end up erasing part of it and making the other part really dark. So you don't want to draw in really dark because it's going to be hard to erase. It's going to take time to erase too. So we're just going to kind of give it a sketch of where we're going to be eventually shading. Okay, next line, we've got -2y is less than or equal to 4x plus 8. You have a choice to make here. You can turn this into standard form and graph your x and y intercept. Or you can turn it into slope-intercept form to graph the y-intercept and the slope. It's going to be totally your choice. For me, I noticed that this -2y is pretty close already to being in slope-intercept form, and so I personally am going to choose to divide this -2 over. Okay. It's going to allow me to turn it into slope-intercept form. Okay, before we get into that, take note really quickly. Equals means it's going to be a solid line. Okay, so when I divide this -2 over to the other side, I'm going to get y dividing that -2, dividing that -2, dividing that -2. Okay, 4 divided by -2 is -2x, and 8 divided by -2 is -4. Okay, so my b is -4. I'm going to start down here, 1, 2, 3, 4. And my m is -2. Because it doesn't have a denominator, I'm going to put it over 1, which means I'm going down 2. I am so sorry, I just realized that was off the screen. Okay, so I'm going to pull this over here so I can point it out again. I apologize about that. So I'm going to start back at the dividing by -2 so you can see what I wrote here. Okay, so we divided by -2 to get the y by itself, and so we have the y. Okay, our 4 divided by -2 is -2x, and then 8 divided by -2 is -4. Okay, -4 then is my b, and so I'm going to go ahead and start down here at -4, and -2 is my m. And since -2 didn't already have a denominator, I went ahead and put it over 1, which means I'm going down 2 and right 1. Okay. Okay, so right here we're going to go down 2 and right 1. So again, you can kind of add more graph if you want to, or you could go back the opposite direction right? So instead of going down 2 over 1, we could come back the other direction with our pattern. And then back the other direction with our pattern. You only need 2 points to make a line, so I mean we could sketch in our line at any point or draw in our line at any point, or you could keep this going as long as you wanted to. As long as you have 2 points, you can connect them. And then remember, this is going to be a solid line because I've got an equals to there. Okay. And then we need to test what side of the line is this going to be on? What side of the line are we going to shade? I noticed 0, 0 is not on that line, so I'm going to go ahead and test 0, 0. We have our x and our y. I'm going to go ahead and plug in to my y 0. So we have -2 times 0 is less than or equal to my x is 0. 4 times 0 plus 8. -2 times 0 is 0. And 4 times 0 is 0 plus 8, which is 8. Is 0 less than or equal to 8? It is. And so we now want to shade in the 0, 0, because 0, 0 gave me a true statement, meaning it needs to be in my solution set of this side of the line. And so I'm not going to shade over here. 0, 0 is not over here. I'm going to shade over here where 0, 0 is. This side of that line. And again, do it light because we're going to end up erasing part of it. Okay, so when I'm looking at my graph here, I need to figure out which of these 4 regions created did both inequalities shade. And whatever that region is, I'm going to shade it in dark. Okay, so this region wasn't shaded at all, so it's not that one. This region was shaded with that second inequality, but not with the first, so it's not that region. This inequality was shaded with the first region, but not the second, so it's not that one. This region I shaded both times. Notice that I have my little shading going this way and my shading going this way, and so this is the region that I'm going to shade in really dark. And then I'm going to go ahead and clean up my graph here, okay, by erasing out of the other 2 regions, just so it's really obvious which region I meant to be my answer. I don't want anyone to be at all confused about what the answer is for my inequality here. Okay, and then we're asked, name a point in the solution. Again, any of these shaded points would work. I'm going to go ahead and pick that one. And this is at x equals 1, 2, 3. And y equals down 1, down 2. So -2. Okay? So here we go. Moving on then. Number 14. We are asked to solve the following by graphing the following systems of equations. So we have y equals 3x minus 1 and y equals -x plus 3. Okay, my b in this top one is -1. So I'm going to start here. My y-intercept at -1. B for beginning. I'm going to begin at -1. And my m, my movement, is 3. And since there's no denominator, I'm going to go ahead and put this over 1. This means I'm moving, because it's positive, up 3 and right 1. So I go up 3, 1, 2, 3, right 1. Up 3, 1, 2, 3, right 1. And I'm going to go ahead and connect that to make my first line. My second one here is y equals -x plus 3. My b in this case, my beginning is at 3. 1, 2, 3. And my m in this case is -1. Since it doesn't have a denominator, I'm going to put it over 1. Which means I'm going down 1 and right 1. So down 1, right 1, down 1, right 1. Down 1, right 1, down 1, right 1. And you can do as many as you want. Again, you only need 2 to make a line. And I'm going to go ahead and connect that to make my second equation here. Or my second line, I should say, here. Okay, and so to solve a systems of equation, you aren't done there. That's just the graph. You need to actually say what the solution is. And a solution for a system of equations, okay, is the intersection point, which is right here in this particular problem. I want to name that point. That's my solution. Okay, and that point is located at right 1, so x equals 1, and up 1, 2, so y equals positive 2. And if you wanted to check that answer, you could take that 1, 2, plug them into both equations, make sure you get 2 true statements. Okay, moving on, we have 15 through 18. We are solving each system algebraically. Circle whether the system has one solution, infinitely many solutions, or no solution. Okay, so number 15 first. I notice here that I have one equation that has already isolated a variable. That x is already by itself. That means that is a prime solution for substitution. I'm going to go ahead and take this 5y minus 8, which is what equals x, and I'm going to stick that where the x is in the other equation. I'm going to substitute right in there. Okay, so we've got 3y plus 2 times, not x, but 5y minus 8. And that's going to equal my negative 3. Okay, now that I've substituted, I'm going to go ahead and distribute that in, that 2. And so we get 3y, 2 times 5 is 10, and 2 times negative 8 is negative 16. Next up, I'm going to combine like terms. 3y plus 10y is 13y. And now I'm going to solve for y. I'm going to get this negative 16 to come over here by doing the opposite. Negative 16, I'm going to add 16. It's going to allow me to cross this off, and I'm going to be left with 13y equals negative 3 plus 16 is positive 13. Last step, I'm going to go ahead and divide this 13 over to the other side. And we get y equals 13 divided by 13 is 1. It's not quite my answer yet though, because I do need a point to be a solution. I've got one part of my point, I've got my y. Now I need to get my x. I'm going to do that by taking this 1 and plugging it back into one of my equations. Or you could plug it into both if you wanted to double check your answer. Make sure you get the same x by plugging into both. Okay, but I'm going to go ahead and take this 1 for now, and I'm going to plug it into that top equation. And I have x equals 5 times 1 minus my 8. And 5 times 1, which is 5, minus 8 is negative 3. And so that's going to be my point. X is negative 3 and y is 1. And since I've got a point, that means I have one solution. Okay. We go. Next up, we've got number 16. Again, I notice I have one that's already by itself, and so let's go ahead and do substitution. I'm going to take this 5x minus 7, which equals that y, and I'm going to stick it into my y there. So I'm going to have 10x minus 2, not times y, but times 5x minus 7. Okay. So now we've substituted. We're going to go ahead and distribute here. We have 10x, negative 2 times 5x is negative 10x, and negative 2 times negative 7 is positive 14. Okay, next up we're going to go ahead and combine like terms. We have 10x minus 10x, which is 0x, and so that cancels away, and so we're left with just 14 equals 8. Okay, well, there's nothing to solve here. My x's canceled each other out. And I just have a statement now. 14 equals 8. And so the question is that true or is that false? If it's true, it's infinitely many. If it's false, it's none. Well, 14 does not equal 8. And so that means I have no solution here. Okay, because 14 does not equal 8. Okay, next up we've got number 17. Number 17, we have x over 2 plus y over 4 equals 6, and 2x minus y equals 12. Okay, you have a couple of options here. One, you could potentially work with the fractions if you wanted to, or two, you could get rid of the fractions. And personally, I like to get rid of my fractions. We've done this since unit, I believe it was 1 is the first time that we looked at getting rid of fractions. Okay. And so to get rid of a fraction, you're going to multiply every single one of those values, each one of these components, each one of these terms in my first equation by my common denominator. And in this case, I have two denominators, a 2 and a 4. And so the common denominator would be 4, because 4 divides into 4 and 2 divides into 4. And if I multiply everything by that 4, I'll be able to get rid of my denominators and I don't need to worry about my fractions anymore. Okay, so let's go ahead and do that. We have 4 times the 1, which is located here, which is 4, divided by 2. 4 divided by 2 is 2. We have 4 times 1, which is 4, divided by 4, which is 1, equals 4 times 6, which is 24. Okay, the bottom equation I didn't do anything to, so I'm just going to go ahead and rewrite that. And I'm now in prime elimination form. Okay, I'm looking for the same number, opposite sign. We'll look at my y here. I already have the same number, and what do you know? Opposite signs. I have a positive and I have a negative. Okay. So we're going to go ahead and add down here, because 1 minus 1 is 0, and 2x plus 2x is 4x. 24 plus 12 is 36. Okay. Now we're going to go ahead and divide that 4 over. We get x equals 36 divided by 4 is 9. Okay, I'm not done yet, okay, because that's only one part of my point. I do need to plug back in. I'm going to go ahead and plug into my bottom equation in this case, because I don't want to deal with those fractions in my top one. You could if you wanted to. You frankly could even plug it into this equation, our modified top one, if you wanted to do that. Okay, but I'm going to go ahead and plug into the bottom. Okay, so we have here our 2x minus y equals 12, so 2 times, not x, but 9, because that's what x equals, minus y equals 12. 2 times 9 is 18. And if I subtract this 18 over to the other side, I get negative y equals 12 minus 18 is negative 6. And so now if I divide by that negative, I get y equals negative 6 divided by negative 1 is positive 6. And so that's going to be my point here. X equals 9 and y equals 6. I've got one solution. Okay, number 18, we're looking at 1.5x plus 1.2y equals 0.6, and 0.8x minus 0.2y equals 2. Okay. This is again in prime elimination form. Okay, and when I look at my second term here, I notice I have 1.2 and 0.2. It's kind of like 12 and 2, and I'm looking at the fact that I have a positive and a negative, so I'm going to go ahead and choose to change that y to make it the same number but opposite signs. Okay, so what do I need to multiply 2 by to make it 12, or in this case 0.2 by to make it 1.2? Well, to multiply, if I multiply it by 6, that'll change it. Okay, but again, if you're going to change one, you've got to change them all. So here we go. Our top equation I didn't do anything to. I'm going to leave that as 1.5x plus 1.2y equals 0.6. In my bottom equation, 6 times 8 is 48, or 6 times 0.8 is 4.8. 6 times 2 is 12, so 6 times 0.2 is 1.2. And then 6 times 2 is 12. Okay, so now we've got the same number, opposite signs. So we're going to go ahead and add down. 1.2 minus 1.2 is 0. 1.5 plus 4.8 is 6.3. And 12 plus 0.6 is 12.6. Okay, so now we're going to go ahead and divide. Divide by that 6.3. We get x equals 2. Okay, now that's only one part of my answer here. X equals 2. I need to plug it back in to solve for y. You can plug it into either point. I'm going to go ahead and plug it into this top one because it doesn't have any negatives. It really doesn't matter what you choose to plug it into. So we have 1.5 times x. X is 2, so 1.5 times 2 plus 1.2y equals 0.6. 1.5 times 2 is 3. Now I'm going to solve for this y. I need to get this positive 3 over here, so I'm going to do the opposite. I'm going to subtract 3. So I get 1.2y equals 0.6 minus 3 is negative 2.4. And then I'm going to go ahead and divide this 1.2 over to the other side. And negative 2.4 divided by 1.2 is negative 2. And so that's going to be my answer here. That's one solution. Okay. Okay, next up we have our back page of our review packet. 3 more problems. Number 19. We have the sum of two numbers is 114 and their difference is 32. Find the two numbers. Okay, for these last 3 we are asked to write a system of equations and solve it. Okay. So in number 19, the first step with all of these is going to be to identify what their variables are, or what the variables are representing. And so in number 19 we need to say, okay, what is going to be x and what is going to be y? Okay, well in number 19 I only have 2 things I don't know. I'm asked to find the 2 numbers. And so x is going to be number 1 and y is going to be number 2. There are 2 numbers. Okay, the sum of those 2 numbers is 114. Sum means addition. And so when I add my 2 numbers, number 1, number 2, x and y, when I add them, x plus y, I should get 114. Remember, is means equals. Okay, their difference is 32. Well, difference means subtract. When I subtract my 2 numbers, I should get, remember is equals, I should get 32. Okay. So there's writing my systems. I've identified my variables, I've written my system of equations. So next up I'm going to solve. 2 equations in the standard form means elimination is going to work well. So let's go ahead and add down here. Y minus y cancel each other out. We had the same number, opposite signs. X plus x is 2x. And 114 plus 32 is 146. Okay, so we're going to go ahead and then divide by that 2, and we get x equals 146 divided by 2 is 73. Okay, so we know one number, 73. So what's the other? Okay, our other number we're going to find by plugging into one of the 2 equations. Doesn't matter which one. In fact, if you want to, plug it into both to double check. So I'm going to go ahead and choose to plug 73 into my top equation there because it doesn't have a negative. And so we have 73, which is what x is, so not x, but 73, plus y equals 114. Okay, and solving for y here, I need to get this 73 over here. It's a positive 73, so I'm going to subtract 73. And I'm going to get y equals 114 minus 73 is 41. So that's going to be my other number. Okay, and again, if you wanted to, you could plug 73 into this second equation as well. Make sure you also get 41. That way you just double check your work. Okay, number 20. Two more. We have Sarah has 26 coins in her purse. All the coins are quarters and nickels and are worth $4.10. How many nickels does she have? Identify the variables and write a system of equations to model the situation, then solve. Okay, so step one, we need to figure out what is my x going to represent, what is my y going to represent. Okay, so what are we asked to find? We're asked to find how many nickels does she have. Okay. And the other thing that we don't know, I'm going to go ahead and make my x my number of nickels, what I'm asked to find. The other thing that corresponds with number of nickels, the other things I don't know, is the number of quarters. So that's going to be my other variable. The two things I'm finding here, number of nickels and number of quarters, because that's what she's counting. That's what she's got. So we need two equations. One's going to deal with the first total, one's going to deal with the second total. My first total is 26, the number of nickels and the number of quarters. When I add those together, I should get 26. That's how many coins she's got in her purse. Okay, her second equation is going to deal with this total, $4.10. Now you want to be careful. Make sure you don't put x plus y equals $4.10. Remember, x and y are the number of nickels and the number of quarters. It doesn't deal with price, which is what this $4.10 is. Right? So we need to make this x and y, we need to put something out front in order to make it correspond to price, to value, money value. Right? Nickels, which is my x, okay, a nickel is 5 cents. And so I'm going to go ahead and make my nickel here 5 cents, 0.05x. A quarter is 25 cents, and so this is going to be 0.25y, right? 25 cents. That's going to be my total, $4.10. Okay, so we have two equations in standard form, and so this is a prime elimination problem. Okay, it's also not going to be that difficult to turn into substitution. You know, we could subtract that x over, and so if you chose to do that route, you might prefer that route. Okay. Two equations in standard form typically is an elimination. So we're going to be looking for the same number, but opposite signs. Okay, so I've got 0.05 here, right? And I've got 1 here. Okay? Well, I can easily turn this 1 into the same number as 0.05, okay, but an opposite sign, so I can make it a negative, by multiplying it by that number, 0.05, and then multiplying it by the negative of that number, because that'll give me then negative 0.05 times 1, which is negative 0.05, the same number, but opposite signs. But remember, if you're going to do that, you've got to do it to them all. Okay. So this bottom equation, I didn't do anything to it, so I'm going to go ahead and leave it as 0.05x plus 0.25y equals $4.10, 4.1. The bottom equation, though, I changed, so we've got negative 0.05x, because that's negative 0.05 times 1. And then we're going to do negative 0.05 times 1 here, which is negative 0.05y. Okay? And then we're going to do our negative 0.05 here times 26. Okay, which is going to be our negative 1.30. 26 times negative 0.05. Okay. So now we've got our same number, opposite sign, so that makes 0. 0.25 minus 0.05 is 0.2. and $4.10 minus $1.30, or 4.1 minus 1.3 here, is 3.8. Okay, and so then I'm going to go ahead and divide by 0.2. Which gives us 19. And so I know my y is 19. Y is the number of quarters. Okay, but in answering my question, they didn't ask how many quarters. They asked me for nickels. So I need to go back, and I need to solve for x. Figure out how many nickels there are. Okay, I'm going to take this 19. I'm definitely going to plug it into the top equation because the bottom one has decimals. Although if you have the time, put it in the bottom one as well. Double check your answer. Let's go ahead and take this 19 and put it in there. So we have x plus not y, but 19 equals 26. And then I can divide, or sorry, not divide, I can subtract, because that's the opposite of positive, is negative. Subtract the 19 over here, and we get 26 minus 19, which is 7. And so I know I have 7 nickels. Okay. And again, if you have the time, it probably would be wise to plug it into the other one as well. Just to double check that you haven't somehow made an error in some way, shape, or form. Okay, plug it into that other one just to double check. Okay, so we're going to go ahead and be moving on to that next one here. Okay. I'm double checking my prior one though. You know, I'm very sorry. On number 20, we're going to have to backtrack. I made an error in my subtraction. Okay, and I'm hoping that you possibly caught it. You should be following along with me, not just copying down here. But right here in number 20, I made an error. I'm so sorry. 4.1 minus 1.3 is not 3.8. It's actually 2.8. And 2.8 divided by 2 is not 19. That's 14. Okay, which means we're going to need to adjust that x. Okay, so here we go, adjusting our x here. Okay, still plugging into that first equation. We have x, plugging in 14, so not y, but 14. It's going to be the same steps, just with 14, not 19. We're going to go ahead and subtract that 14 to the other side, and we get x equals 26 minus 14 is 12. There we go. That's our answer. If you did catch that, by the way, I commend you. Well done. Okay, so now we're going to go ahead and move on to that next one, okay, which is number 21 here. Okay. So, number 21, which says, John paid $34 for 2 algebra and 3 geometry books. He paid $36 for 3 algebra and 2 geometry books. What is the cost of each book? Again, we're asked to write a system of equations, explain the meaning of the variable in the context of the problem. Okay, in this one, we're asked to find cost, and so that's going to be my variable. Okay, x. Okay, right here I'm explaining the meaning of the variable. So x is the cost of, and it doesn't matter which book you call which. I'm going to go ahead and call my x my algebra book. It's the cost of the algebra book, which means y is going to be the cost of the geometry book. Okay. So here we go. Next we're going to write our system of equations. Our first scenario here is he paid $34 for 2 algebra and 3 geometry. Okay, so he paid 34 for 2 algebra, so 2 x's, and 3 geometry, so 3 y's. Okay, next equation, he paid $36 for 3 algebra, so 3 x's, and 2 geometry, 2 y's. 2 equations in standard form means elimination's up. We're looking for the same number, opposite sign. You can change either one. Both of them are positive in this case. Both of them are going to have to change, so it's not really like one's going to be better than the other. Okay, so it really is going to be your preference. I personally am going to go ahead and choose to change the x's just because I feel like it. I chose to. Again, there's not really one that's better than the other. Okay? When I'm looking at 2 and 3, I know 2 and 3 can both be made into 6. Now I do want to make sure I make one of them -6 because we want to have one be a different sign, opposite signs, same number, opposite signs. And again, doesn't matter which one you choose to do. I'm going to go ahead and choose to make the bottom one my -6. So the top one, to make it 6, I'm going to multiply that 2 by 3, which means I want to multiply everything in that top equation by 3, maintain equality. The bottom one, to make it 6, I'm going to multiply it by 2, but because I want it to be negative, I'm going to make it -2. Again, make sure to maintain equality. Do it to all the other terms in that equation. Okay, 3 times 34 is 102. Okay. 3 times 2 is 6, and 3 times 3 is 9. -2 times 36 is -72. -2 times 3 is -6x. -2 times 2 is -4y. Okay, now that we've got the same number, opposite sign, we're going to add down. That's 0. 102 minus 72 is 32. 9y minus 4y is 5y. I'm sorry, 102 minus 72 is 30. Okay. And if 30 equals 5y, if I divide 5 over to the other side, 30 divided by 5 is 6. Okay. And so y is 6, and since y is the cost of the geometry book, I know that my geometry book is $6. Okay, algebra book then. It doesn't matter which one you plug it into, so pick one. I'm going to go ahead and pick the top one because it has a slightly smaller number. And if you have the time, plug it into both to double check. So we have 2 times x plus 3 times my y, which is 6. So we get 34 equals 2x plus 3 times 6 is 18. Solving for x, I'm going to go ahead and subtract this 18 over to the other side. 34 minus 18 is 16. And then we're going to go ahead and divide that 2 over to the other side. And so we get 8 equals x. And I know x, which is the cost of the algebra book, is 8. And so $8 is my algebra book's cost. Okay. So there's your Unit 4 review. Good luck on your test. Good luck studying. And have a good day.